692 top K frequent words. Given an array of strings words in an integer K, return the K most frequent strings. Return the answer sorted by the frequency from highest to lowest. Sort the words of same frequency by their lexicographical order. The heck? So we got an array here. I love Leetcode, I love coding, K equals 2. Output is I love, and the reason is because I and love are the two most frequent words. Okay. Note that I comes before love due to a lower alphabetical order. How does sorting work for alphabets? So, we got sort function, reverse equals true, right? The parameter. So, descend, I would say, yeah, I think that'll be fine. But anyway, so let's say, got the day is sunny, sunny is sunny day. So are we printing out all the, no, the frequency, I see. Okay, so how do we do this? Well, we could create a dictionary, or we could create a dictionary of it. I'm wondering if we could use a counter object, because then we could have all the counts of all the words, right? And then with that, what can we do with the words? We can get self-most, so values from there, and we can iterate through all the dictionary values and just maybe keep ones that have a value of over at least K, and then from there we could just sort it, right? Couldn't we? So I'm thinking, okay, create a counter object. So we're creating a dictionary of O of N, and then we're gonna iterate through a list of values, check if it's greater or equal to K, and if it is, then we'll store it in a list, right? So that worst case, that would be N operations, and then after that we'll sort it, and so worst case sorting is N log N. So I wonder if this is too simplistic of thinking about it, but we need to count all the words anyway. So let me just give it a shot. I just realized that you couldn't see me this entire time. Let me, just to put some human aspect to it. How do I do this again? I forget. I am so out of it right now. The heck? Stay. Oh, gosh. Ooh. I'm so sorry. This is not float on top. There we go. Alright, from collections, import counter. We're going to create a dictionary with this. A counter object is going to be a counter. We're going to pass in iterable words. So because we already have it by words, yeah, all of them are going to be keys. And then we're going to have filtered K, okay, which is filtering by the length of K, which is a number. If for, let's say, key, or in this case, word count in counter object dot items, let's just do items, right? So we're iterating through all of the items, so that's n times. So we're going to say if count is greater or equal to K, then we're going to say, we're going to append it, let's append the word, right? And then now we have a list of all the words, but they're not in order, right? So the lexicographical order is pretty interesting. So I wonder if we could just do less than or equal to. So if we just do sort, I wonder if that would be good enough, or do we have to? let's say for filtered k dot sort lambda. Don't I need a key there? I forget. Key lambda x that what the heck am I doing? I'm just gonna, well, let's say you need to use a sort function, right? By the way, this is gonna sort it in place, so I think we could just turn filtered k. Turn lower, go word itself, word 1, word 2. Let's say return if one less than word 2, word 1 else return word 2, I think. Sort the same frequency. Sort by the frequency from highest to lowest. Oh wait, so we're gonna return the list by the number of frequencies first, then the sorting order. Okay, so sorting can be an issue here. So I see. So we create a dictionary and then we go through all the items and we add all of them to a list based on the length, right? And now you want the greater length to come up in front, or at least the count of it. Oh, interesting. So this is trickier than I thought. So word count. What if we appended word and count, right, together as a tuple? So we have the word and the count, and then sort key equals self dot return lower. Okay, so we're gonna send in filter. Oh, I need to get better at sorting. Filter dot k equals key equals self dot return lower. That wouldn't work. Actually, now I'm confused. Why am I opening data list? Oh my gosh. Let me check something. Python. So let's say return lower. Close. Word 1, word 2. Let's say I do the sort key equals return lower. That wouldn't work because it takes 2 arguments, and that wouldn't work because yeah, again, no 2 arguments. So what 2 arguments am I gonna give? Yeah, I gotta get better at the lambda thing. But let's say I was using lambda x, right? So let's say we wanted to sort it by, this is like a function. Oh my gosh. Actually, let me see if I got it right. So if I do li.sort key equals lambda x, length of x. Then I get the fuck. Oh, I need to sort key. Can't curse in it. Yeah. Python sort function. Oh, that's key retro key equals len. Say what a function. Custom functions. Key equals get age. Oh, okay, so we just pass in the function. So also for every element, then we're gonna do that. Okay. So for every element, why don't we so what if we did reverse equals true? So what's more important here, the count or the length? The count, right? So the length, or I mean, turn lower. Self-word. Return length of word. So based on the length of the word, actually, word 1, right? For each word, we're gonna go into the count. So we're gonna say key equals return lower, like that. But then when we the count, we also want to do lexicographically. How do we do that? Return lower is not defined. Yeah, so this is the tricky part. The sorting part is the tricky part, right? Not really sure how to do that right now. Just to show you. I mean, the basic idea is there. Let me just run this again. It's not gonna work because x1, we're counting it on the count. Filtered. Yes, okay, lambda. Am I using lambda wrong? Key lambda x. Where's okay. So I too love to. So we want to sort by that. So let's do that again. Lower count self return, and we're gonna have an element, and we're going to return the element 1. Okay, so if I do that, return filtered k sort key going lower count. The count is not defined. How did I do it earlier? Did I do it earlier? Oh. Self.lower count. Still wouldn't get anything. I wonder why. Okay. Get that. But we can't store. We get none. Maybe because that just doesn't work. Let's go to W3. Sort equals my phone. Yeah, return E, return length of E, key equals my phone. Oh, remember, this does it in place. Right, so I don't need to. Okay, sort is in place. So if I do that, then yeah, that works. But how to sort by, so the question is, how do you sort by count? And then how do you sort by the lexicographical order? So how do you return the answer sorted by the frequency? So how do you sort by frequency, then lexicographical order? How do you sort on two frequency, then order? There we go. Sort counter by frequency, then alphabetically. I'm trying to use a counter to sort letters by occurrence. Similar, I'm sorting words and put the frequency into alphabetical order. So this person, okay, got the count of it, but you want to order it by frequency, then by alphabetical order. So that's my question. The answer is, well, there's multiple answers. Let's try this first. It sounds like your question is how to sort the entire list by frequency, then break ties alphabetically. Yes, you can sort the entire list like this. Okay, sorted to return it. We're going to sort the items. Okay, so we're sorting the dictionary here, or tuples, sorry. We're sorting the tuples, and the key is lambda. We're using for each item. Oh, what is that? What is that? So this is the letter, and this is the count, decreasing. So by decreasing count, that's very interesting. So in the tuple, by decreasing count, we're going to order by decreasing frequency, and then the character of the word. So we got 2, 1, 1, 1, 1 here. And then 2. Wow. So, and then we go up from here. So this is descending. This is ascending. So we're descending by the count. We're descending by the frequency, and then we are increasing by the alphabet. If you want the alphabet to be a dict still, we don't need it, but I guess. Oh wow, you can use an ordered dict to do all this, really? Well, but then, he's putting it into an ordered dict. That's very interesting. Let me check this one. You can try, you have a counter object, then for A for AB in letter that count items if B equals 1. So that's confusing. Let me try that. That was really interesting. So we have the word count, right? And I'm just going to sort this in place. We're going to say, I wonder if we can use this here. So negative. So we're first frequency, ordering by frequency. So that's the first index, right? And we're doing it in descending order. And then we're lexicographically. So I becomes love. Okay, so 0. I love. And then we're returning a list, right? So I wonder if there's an easy way to convert a tuple to a list. But let's say this all equals list for I in for a word count in filtered K. We're gonna say append the word, and then we're gonna return this. Try that. Let me try submitting it. Oh, that didn't work. Okay, why? Output the. We didn't get is sunny day. Why? I'm gonna get rid of this, by the way, and I'm gonna try lambda. So I'm gonna do sort. Key is gonna be lambda. So we're gonna do so decreasing frequency. So of 1, then increasing frequency of the alphabet itself. So return. Okay, let me try running it again. That didn't work. Again, I need a print filter K each time. List for word count and filter K. We're gonna append word up, and then we're gonna turn res. That worked, but here we're only getting the. I wonder why. 4. Well, why do we want is when the count is 3? Why do we want sunny when the count is 2? And day when the count is 1? I think I read the question wrong. Return the K most frequent strings. Oh, I see. Oh, shit. Oh, I see. So I want 4 words, so we get 4 words. I see. Is it guaranteed that K is in the range of 1, the number of unique words? Oh my gosh, can you solve it in n log K? I think so. Yeah. But let's try this again. So we want K words. So we sorted it for I count. Okay, let's say we have a counter, right? Counter plus equals 1. If counter equals K, then we're gonna break. What? Oh no. So we don't need to. We're just gonna append everything like that. So we're gonna do this O of n times, and then we're gonna sort based on that. So again, we have a counter object, we have a list, and then we're going through the counter object's keys and values, and we're appending as a tuple each word in a count. because we have all of that sorted, and then we'll sort that using a lambda function based on the tuples decreasing frequency and also lexicographically based on its word. Sure. Okay, and then we'll have an empty list, and we're going to have a counter because we want up to the k words, right? So we're going to go to filter k. We're going to append word, increase the count. So 1, 2, 3, 4. Boom. We're going to break and then return res. Let's run code. That works. That works too. Okay. So that was pretty neat. I did not know about like this kind of sorting. So yeah, that was pretty cool. What is the time complexity of this? Well, we create a dictionary object, and that's most n words, right? Worst case. Well, yeah, n words. And then for each word, we're gonna append it to a list. So that's at worst n times. Let's say each word is unique. And then the logging portion is where it takes log n time. So first we're sorting by frequency. So that's log n time. N times. And remember, we're doing, I guess that's based on log k. Is it? I'm not so sure, honestly. That's a little confusing for me. But the main part being that you can sort using negative signs. Positive, I want to increase that. Okay, cool.